All right. So today we're learning about the three equations of motion. First of all, when are they used? They're used when we have a uniformly accelerated motion only. So uniformly accelerated motion. And what that means is that your acceleration cannot be zero and that the acceleration also can't change. So it can't be a varied acceleration. You have to have the same acceleration throughout that motion. So that's the condition. Now, what are these equations? The first equation, it relates the final velocity with the initial velocity and acceleration and time. Again, velocity and acceleration, these are vectors, so I'm going to put a little arrow on top of it. So this formula says your final velocity is equal to whatever the initial speed you started with, which kind of makes sense, right? You started with, let's say, 10 meters per second. That's your initial velocity. And then you accelerated for a certain period of time. You're going to add that accelerated period of time. So acceleration times time. Remember, when we did acceleration time graph, we said the area under that graph gives us velocity. And what is the formula for area? Length times width. So kind of like, um, length times width. We said the area gives us velocity. So it's like the initial velocity plus that gain in velocity when you accelerated for a specific period of time. You add those two up and you get your final velocity, right?
Yeah.
Quite intuitive to understand that. Okay, so that's the first one. The second one, it relates displacement. So it says your displacement is the initial t. So, and that is if you were traveling at a certain velocity for a certain period of time. Yes, you covered that distance. But then you also kind of, let's say, accelerated, and that's going to be half a t squared. And yeah, so again, that's your displacement. This is best understood. Sorry, give me 1 second. Sorry, I was getting a call. That's the second formula. Third formula, it relates velocity, acceleration, and displacement without taking into account time. So if there are if you have a question where you have no information about time, but you know the other variables, you can use this formula. So this says final velocity squared is the initial velocity squared plus 2 times the acceleration times the displacement. And it has no time. So if you actually notice, you can use the first equation when you don't have information about displacement and you only have information about time, acceleration, and velocities. You can use this equation when you don't know anything about your final velocity, right? And you can use this equation if you don't know anything about time. And in some of the complex questions, it would have to be a combination of these equations that you would have to do. Maybe you don't know time, so first you find time and then you have to find displacement, so we might use a combination of these equations as well. Why in the textbook and in some of the teachers and formula sheets have 5 different equations? Because sometimes they put negative here and here or here. And I think that is best understood, not in terms of like having 5 different equations, but you can understand this in terms of how you would relate the direction of motion and the direction of acceleration. And let me explain what I mean by that. So these are the equations. Let's come back to these equations. But first, let's understand directions. So we're going to do understanding the direction of motion versus the direction of acceleration. Sometimes we think that the direction of motion and direction of acceleration is always the same. It is not the case. It is the case when you press on the gas pedal of your car, you're accelerating and it moves forward. That is the case when acceleration and motion are in the same direction. But what happens when you press on the brake pedal, right? So you see a red light and your car is obviously going forward on the road. So let's just try to make that road, right? You see the red light, your car is moving in this direction. So this is the direction of motion. Now, instead of trying to hit or press on the gas pedal, you're pressing on the brake pedal. So you're kind of trying to slow down. The acceleration is no longer acting in this because you're not accelerating, you're kind of deaccelerating. So you're trying to stop. So acceleration is going to act in this way. So the acceleration is going to try and stop you, right? And that's when your car will come to a stop, right? So when you're pressing on the brake pedal, the direction of motion and the direction of acceleration are opposite. Okay.
Okay.
So this is when you press, when you're braking the car. And then when you hit on the gas pedal, you're trying to accelerate it forward. So the direction of motion and the direction of acceleration are in the same direction. Now, how does that impact your equations above? Remember I said that when we did 1.1 through 1.4, when something is, especially a vector, is acting in the opposite direction, we have to put a negative just because to indicate that it is in the opposite direction. For a car on the road could go in any direction, right? So there's no specific by default, like, oh yeah, this is your positive direction, so this is negative. You get to select whatever you want your positive direction to be. So at the beginning of each question, so for me, I usually try to take up as positive and um, right as positive, and anything going left and down, I try to stick to this that it will be negative. However, you could choose that, oh, this is the positive direction, and so this is the negative direction, and so on and so forth. Like you could do that. Um, but usually try to follow one direction convention and then stick with that. Let's say I wanted to use the equations of motion. Maybe let's just look at the first one, right? Let's look at the first equation, which is V final is V initial plus A T. V final equals V initial plus A T. Anything that's vector, you have to account for its direction. When I say direction of motion, this is where the, velocity of the car is going this way or whatever. So velocity is going in the forward direction, which is positive. So I'm going to keep this positive. Again, V final, V initial, same thing. Let's say it's just going this way, positive. However, now my acceleration is actually going the opposite way. And this, my default diagram says that this must be the negative direction. So you just put a negative in front of this. Time is scalar. We don't care about the sign. So you see the first equation turns into this with a negative only because acceleration was acting in the opposite direction. And this they would call it like the fourth equation. But instead of like memorizing all this, I think just remember the three equations with positive signs and then think about the directions and change them accordingly as you go. Does that make sense?
Yeah, it's fine.
Okay, okay, good. And then for this one, because acceleration and the velocity, they're both going in the same direction, in the positive direction. So here, all the signs are still positive. So the equation here is still the same. Good?
Mm-hmm.
Okay. So this is one example. I'm going to show you this with another example. This is the example of I have, let's say, a ball, and I'm going to throw it vertically up, and we're going to analyze its motion. Okay, so motion of a ball thrown vertically upwards. Here's the ball. Now you volunteer at the summer camp, I guess, the football, the soccer camp.
Mm-hmm.
So maybe you should try this. Let's try to simulate this. Now I'm drawing it like this, but imagine it goes in the straight line and then comes back exactly in that straight line, right? So, okay. Um, Question 1. Why does the ball come down? You threw it up, why does it come down? Right?
Gravity.
Yeah, exactly. Gravity, right? So on the road, when you're moving left and right, like you're driving your car, the acceleration comes because you press on the gas pedal. So, the engine works and the car's like, accelerates forward. But as soon as, like, when you throw a ball up, right, as soon as it leaves your hand, there's no more force or acceleration acting on it. Like, yes, you gave it that little energy to go up, but once it leaves your hand, it's no longer being accelerated by any force in the upwards direction. Like nothing is, you know, pushing it up more and more. Not like a rocket, because with the rocket, like there's fuel and it's constantly pushing it up, right? But as soon as the ball leaves your hand, there's nothing that is further accelerating it up. You give it that little energy, and that's all it has, and it's going to use that energy, reach a max height, and then it's going to start coming down. But what's happening is throughout that motion, because you're standing on Earth, right? We're on Earth. What does Earth do? Earth always wants to pull things down. And how does it do that? Like you said, because of gravity. So the acceleration, actually, another question. What, so let's say you throw the ball up and you threw it at the speed of like 10 meters per second. What happens to that velocity as the ball travels up? Option stays the same, increases, decreases.
Increases.
Okay, that's a really good guess. That's what all the students, most of the students say. Think about it. If your velocity kept increasing as you threw it up, wouldn't your ball just go into space?
Oh,
It'll
so
just keep going.
decreasing.
Yeah, it
Okay.
decreases, right? So you throw it with very like a lot of energy and force, and it kind of goes up, but then it stops and then starts coming down, right? At the
Mm.
highest point here, what would happen? The velocity actually goes to zero. It stops momentarily and then starts traveling down. So velocity is decreasing. Now, when velocity is decreasing, what does that mean for acceleration? Do you think there is some acceleration, no acceleration, or yeah, just two options? Is there any acceleration? Now think back to the lesson we did the other day. When is there no acceleration? When is acceleration zero? Do you
When
remember?
it's like when a car if it like brakes or
When it stops,
yeah.
completely stops, yes, there is no acceleration. But also if it keeps traveling at the same velocity, right? Like let's say
Mm-hmm.
keeps traveling at like 60 kilometers per hour. Um, then there's no acceleration either. Because remember, what is the definition of acceleration? Change in velocity over time,
Oh, because there's
right?
no change.
If there's no
Oh.
change, then it's like zero over whatever times that's just going to be zero, right?
Mm-hmm.
So acceleration is zero only for two cases, right? One, when the object is not moving, so it's at rest, like you said. So it's if the car is just stopped at the traffic light, no acceleration, yes. But also case number two is when velocity is constant, then there's no acceleration. But in this case, velocity is decreasing, right? It means it's changing, either increasing or decreasing. They both represent change. So because velocity is decreasing, yes, there is acceleration. Now the question is, where is this acceleration coming from? Because as soon as the ball leaves your hand, it like your force doesn't matter anymore, right? So where is this acceleration coming from? What is decreasing the speed of the ball as it goes up? Any guesses?
So when the ball's going up, like what's making it like
Slow down. Yeah.
that? Like the speed is kind of like someone like threw it up. So then
Someone,
the speed kind of like decreases, like it doesn't have as much like power. It goes like
yeah,
down because the person's like not throwing it up anymore. It kind of starts and then like slows down.
it does slow down. The reason it does that is there's gravity. If there was no gravity and you threw the ball up, right, it would continue going up forever because there was nothing to stop it or slow it down. This kind of brings me to Newton's first law of motion, actually. It's interesting. Newton's first law of motion says an object at rest will continue to be at rest, and the object in motion will continue to be at motion unless there is an external force that disrupts that state of motion. We will do this in chapter 2, actually, with dynamics. But essentially, the fact that velocity is slowing down, like you said, is because the gravity is providing that acceleration. So where does this acceleration come from? It's called acceleration due to gravity. So gravity, when it pulls objects towards itself, provides that acceleration. So it's acceleration due to gravity. That acceleration due to gravity, we just call it g, small g, and the value is always the same, 9.81 meters per second squared, as long as you're on Earth. If you go to moon, if you go to Mars, then the acceleration due to gravity changes because, the size of those planets and moon is different. So the G would be different. But as long as you're on Earth, you will always use G as 9.81 meters per second squared. This is very important. Okay. But this is only for vertical motion. Because gravity only it cares about the up and down motion. Like if something's going left and right and like a car accelerating, gravity's not going to do anything because the car doesn't move up and down. The car moves left and right. So gravity only acts vertically. So this is only for vertical motion. Okay. And it always acts downwards because Earth, right? Earth's always going to pull things down.
Hmm.
Okay. Does this make sense?
Yeah.
Okay. Perfect. Now, based on this, we're going to do an example, understanding the directions, okay? So we're going to continue understanding directions. And this time we're going to do it with a vertical motion. This is the case of a ball. So somebody is standing on the 8th floor of a building, and they're in their balcony, and you're down, and they have a ball in their hand. They're not pushing it down, but they just have it in their hand and then they just drop it. Okay, so this is the ball. They drop it and it's coming down from like whatever floor, and this is you standing on the ground. And this was the 8th floor. And let's say I give you a question and it turns out you have to use um, this equation. and we're just trying to figure out the directions and stuff, okay? Again, choose default direction before you even begin the question. I think that's the first thing you should do. Choose your default directions. A lot of the motion is happening down. So if you want your downward direction, you can take that to be negative, and upward direction is positive. So anything that moves up or acts up, you're going to choose that as positive. Anything that goes down, moves down, you're going to choose that as your negative direction. You could do that. You could also do the opposite. Like you could say, oh, for my default direction for this question, I'm going to say anything that goes down, downward is positive and upward is negative. Up to you. Like there's no right or wrong approach. So you choose your direction. But once you choose it, you have to stick with it and you have to do everything based on those directions. Good?
Okay.
Okay. I'll ask you, what do you want to choose? Do you want, let's draw this little Cartesian. Which directions, up or down, do you want to be positive?
Up.
Up, positive. Okay, good. So anything that is traveling down, acting down, going down, everything would be negative, right?
Mm-hmm.
And then, well, left and right in this case doesn't matter because it's only a vertical motion, but let's say you chose this. So just choose your directions like this on the side. Okay, so displacement. The ball is going to travel from here all the way to the ground. What should be the direction of displacement?
Negative.
Perfect. Good job. Negative. Velocity. Again, time, we don't really care, so I'm just going to put time as whatever. Velocity. It's going to travel down. What should be the direction of velocity?
Also negative.
Also negative. Correct. And acceleration always acts downwards, like acceleration in vertical motion is due to gravity, right?
Mm-hmm.
Which is also acting down. So everything's negative, which means in some cases, they'll use this exact same equation with positive signs. It's only because, honestly, if you just multiplied everything with negative, all the signs change. But also, some people would just take the negative, sorry, they would take downwards as a default positive in this case.
Mm-hmm.
So once you do a lot of questions, you'll get an intuitive understanding of what is a good direction to be chosen as positive, because you would see, okay, it's going down, displacement is down, velocity is down, acceleration's down. So I might as well just choose my downward direction to be positive. But it's something that will come with more and more practice and intuition. Um, this is perfectly fine, by the way. If you did this equation, absolutely, you would get the same answer. It will be the correct answer. We just prefer the positive because, less chances of making an error, but
Mm-hmm.
they're both equally correct and you would get the exact same answer. So very good. This is perfect. Um, the other example that I would do here is if the ball was traveling up. This is interesting, right? Because the ball is now going from here. Let's say now you throw it back so the person on the floor could catch it. So it starts here. So this is like initially things are here and finally things are over here. And let's say we're doing this. And let's say this is what I'm finding. So I don't know what final velocity is. I don't know. Um, what would be the direction of the initial velocity in this case? Oh, sorry, before we do that, let's just reestablish that these are our directions, right? Positive and negatives. So, which direction did you throw your ball? What is the direction of velocity?
Positive.
Positive, very good. Where is the acceleration due to gravity? Where is acceleration acting?
When you throw the ball up.
Mhm.
So also positive.
No, the acceleration is due to Earth.
Oh, so
Earth
it's like
never,
when it comes down. Oh,
yeah,
okay.
always. 100% of the times, gravity will never act up. Gravity is always going to pull you down, right?
Oh,
So,
so are acceleration and gravity like interchangeable? Like you can use like the
mm,
same word?
yes,
Oh, okay.
yeah. Only in vertical motion, because in vertical motion, where is the acceleration even coming from? It comes from gravity only, right?
Mm-hmm.
So
Okay.
in the vertical direction, acceleration is always the acceleration due to gravity, which is 9.81, always. But again, only for vertical motion and always acting down. Good?
Okay. Yeah.
Perfect. So yeah, you're right. So it'll be, well, technically, let's just do A if that's better. So it'll be like this. This would become the formula for final velocity. And we know that acceleration is the same as g, so it's 9.81. But what I'm trying to do here is teach you that you can only use three equations and you can always predict the signs just by choosing the direction uh, of of your own. Like it's up to you. But once you decide, okay, these are my default directions or my reference directions, continue with that same reference point throughout the question and you'll be fine. Okay. Um, okay, that's all that I have to tell you. I think it's better that we just get started with questions. For the first part, we're going to get started with questions, which will not involve vertical motion. Vertical motion is 1.6. So I'm going to just do these equations and we're probably just going to do like east, west, like left, right kind of questions. All right. So I'm going to write this question now. So there is a football player initially at rest. So there's a football player. What does that mean if I say initially at rest?
Like at 0?
Yes. What is zero? Acceleration, velocity, distance? Usually, when they say this, they usually mean velocity. So initial velocity, zero.
Okay.
Okay. So he's initially at rest and then accelerates uniformly. So when you see the word accelerates uniformly, it means you have to use one of those equations, right? And she accelerates uniformly, runs down the field, and when she does that, she travels 17 meters in the east direction, and she does that in 3.8 seconds. And the question is, what is her final velocity? Let me. Okay, and because you probably still haven't memorized these equations, I'm going to copy paste them here for you. Okay. So always have these equations in mind. Select, first of all, which equation would be useful, right? So which equation would you use? Wait,
Probably the first
yeah,
one?
the first one.
Yeah.
Um,
Or the third one, but the third one, doesn't the third one have like that too?
yeah.
So, wait, is that better?
Hmm. Um, yes. I think third one is better because you do know, but you for each of these equations, there's one little thing you don't know the acceleration in any case, right? Because it's not given to you. So yes, we will use the third equation to find our final velocity. But for you to be able to use the third equation, because you need to find your final velocity, but you don't know acceleration. So this is the two-step question where it's like, yes, we do need to use the third equation. But before we do that, let's find acceleration. How do we find acceleration? Also, acceleration here is not 9.81 because it's not a vertical motion, right? Like it's a car or a football player accelerating. So we're gonna find acceleration. So the strategy, always the first thing you should do, analyze the question. Okay, this is what I need. This is the equation I should use. Okay, to do that, I need to find this. So like always strategize. So the strategy here is use third equation. You could also use the first equation, or in any case, if even if you use the first or third, it doesn't matter. Third or first equation. First equation to find VF. However, what do you need? What we need, because acceleration is common in both. So, but we need to find the acceleration first. Now, my question is, how would you find acceleration? Think about what you have given in what you're given in the question already, and which equation would be able to help you find the acceleration.
Probably the third one because it has distance or displacement.
We have displacement, but we
Yeah.
don't have final velocity or acceleration, right?
Right.
Here's what helps. Let's state what we're given. Initial velocity we're given is 0. Displacement we're given is 17 meters in the east direction. And time we're given is 3.8 seconds. And the first goal is to find acceleration. Now, maybe this will help. Now think about it. Which of these equations involve all of these variables? Isn't it the second one?
Yes.
Right?
Wait,
Because you
so then how would you find the acceleration if it's like with the time in the third? Like it's like plus.
you can always rearrange,
Oh, okay.
right? It's like plug the variables and then solve for X kind of thing, right?
Oh, okay.
Yeah. Oh, were you looking at like the isolated ones only? Yeah, you could.
Yeah. I
Okay.
just got
Yeah.
a little confused.
Okay.
That's
Yeah.
okay.
No, that's perfectly fine. You can always rearrange. So I'll show you. Okay. Good. Good that we cleared that. So let's do solution using equation 2. So equation 2 says displacement is v initial t plus half a t squared. Now, it's just left and right, and because displacement is in this direction, let's just consider east to be our positive direction, and west could be negative, okay? So I'm gonna just, my default direction is east, is positive. Because again, I don't need direction for time. Initial velocity is just 0, right? So it doesn't really matter because it's not really moving initially. So displacement, that's why this is going to be a positive number here, 17. I'm going to just by default take it as a positive direction. Now, because velocity is 0, 0 times anything is just 0, so that's gone. And then you have half a and then t squared. Again, t doesn't really have any direction, so we don't really care. So it comes out that 17 is equal to half a and then 3.8 squared. And then you can rearrange, like you can multiply by 2 on both sides. So you get 2 times 17 is a times 3.8 squared. You can solve it, like, what is I don't have my calculator, my bad, but you could solve it. Let me just do that here. 3.8 squared. That is 14.44. And 2 times 17 is just 34. And this is 14.44. And then to find A, what would you do?
You just divide on both sides.
Exactly. You divide on both sides by 14.44. Whoops, 13.44. And so acceleration, if you do that, comes out to be 2.3545. I'm just going to say 2.35 is good enough. Okay, so that is our acceleration. Good?
Yeah.
Okay. Now that we have our acceleration, we can execute our first strategy, which was to use either equation 1 or 2. Sorry, 1 or 3. If I was given a choice, I would just go with 1 because it's much simpler looking than um, 3. 3 involves squares and stuff. But again, up to you, use any. So then I'm just going to use equation 1. You can always try different equations as well, um, just to see how different equations will still give you the exact same answer. Practice. Again, initial velocity was just 0. Acceleration we just found is 2.35. Time was 3.8. So it's basically just 2.35 times 3.8, and we get 8.93. Another good thing that I didn't do, but you should do, is use the units everywhere. Because then you can see, like, one of the second squares in this cancels, so you get the meters per second, which is the unit of velocity. And I should have done that everywhere here as well, like east. So this would have been, east, and this would have been second. And so this would be considered the final correct answer, 8.93. Are we good?
Mm-hmm.
Awesome. Once you have your answer, go back to the question and look for the sig figs. So this has 2, this has 2, which means the final answer should also have 2 sig figs. So technically, just 8.9 would be, just so that we're complying with the rules of sig figs. Is this okay?
Wait, what's a sig fix? Wait, what's that?
Oh my gosh, yeah, I never taught you that. So when you start physics, they will probably start with yeah, let's do sig figs. Um, or maybe let's just do that in the next class. Significant figures are, it's it's okay. We need like 15 minutes to go over sig figs, but essentially when you measure something, right? Um, there's only so much accuracy that you can have in your measurements. For example, when you measure something with a ruler, right? Or even in labs when you have those graduated cylinders. Let's say you have a normal ruler. You're measuring the length of like a leaf or something. And maybe you can say, oh, it's 2.51 centimeters, which is okay. It is fine. But maybe there's another student and he's saying, oh, you know what? My leaf is like 2.38459 centimeters. That's not accurate, right? Because the ruler doesn't have as many, um, it's not a very precise instrument to do these measurements. So yes, you can report it to like 2 figures that can be considered accurate. The last one is still, it's whatever. Like you can be 100% certain about 2 and 5, and then one could be like some other could say, oh, it's actually 2.52, and somebody could say, oh, it's actually 2.50, and you could say, no, I think it's 2.51. So that last digit is a little still uncertain, but you know, if somebody says this, you're like, how did you even get that? Like how are you getting all these decimal places, right? So this is kind of like the idea that yes, when I do the calculations, my answer is like it could be a really long answer, like 8.9345, like a really long answer. But how many of those digits are significant? Because physics is based on real life application questions. It's not really math that you can have infinite um, numbers and they're all significant. Like it wouldn't make sense for me to say, oh, my speed is 8.9367 or whatever, when I only know the time, my time is only accurate to two significant digits. So is my distance. Like these are rough measurements. So using those rough measurements, you can only report your answer to as many significant figures as there are in the question. Now,
Oh, okay.
yeah, but how do you calculate significant figures? And what if distance was like 17.5 meters, but time was like 3.2 seconds? Now this is 3 and this is 2. Which one do you select? You go with the lower accuracy one. So because that will limit the accuracy of your question of your answer, right? So it's that's the reason why we have to comply with the rules of sig figs, because your answer can only be as accurate as the measurement, right?
Okay.
Um, so it's that. I hope that that was clear. But we could do another class on how do you calculate the number of sig figs. For example, the number of sig figs in this question in this is 2, but the number of sig figs in this measurement is 3, right? There are rules, and
Uh,
it's basically the presence of a decimal that makes something significant. And here it's just these two. So the 0, if there's no decimal, the 0 doesn't count as a sig fig. So there are certain rules. I can go over those, but they're very straightforward. There are only a few, like 4 or 5 rules. But in most of your physics questions, it's going to be pretty straightforward in terms of you will be able to look at the question, be like, oh, this one has 2 sig figs, this one has 2 sig figs, so my answer should also have 2. However, if this had 2 and this was like 3 sig figs, then you will choose the lower number of sig figs for for reporting your answer. So like still 2. Yeah. Am I making sense?
yes, I think so. It's okay.
Yeah, okay.
Yeah.
Um, yeah, but it was pretty, like we did it in a rush. We could do a full 15-minute block just on sig figs, and I will explain to you what these are. But for now, just yeah, it's not too important. You just have to like just round your answer based on what the question is. That's all it is. Okay. All right. So this is it. This is actually 1.5 and 1.6. I'm I wish, you know what? I'm gonna do one more question before we end the lesson because we did start late. So I'm going to copy and paste some of the questions from the textbook. You can do these for revision and practice, but this is some of the questions from 1.5 right here. And I'm also going to do some questions from 1.6. 1.6 is all about like um, acceleration due to gravity, so vertical motion. Those are 1.6 questions. Yeah, so those are 1.6 and this is 1.5. I will do another one question from 1.5 and then one question from 1.6 and then we'll end. Good?
Okay.
Okay. So here, let's attempt 5. And we can attempt 6 as we can attempt 3 and 5. And I'm not going to do the whole question, but I'll ask you what you think. Let's start with 3. A helicopter is traveling at a velocity of 15 meters per second west. Excel and it accelerates uniformly at the rate of 7 meters per second east, 7 meters per second squared east for 4 seconds. What is the helicopter's final velocity? I'll give you a simple algorithm that you should follow when you do these kind of questions. So the algorithm is, one, if possible, do a sketch. A sketch really helps, like a diagram. Two, you have to choose your default directions. And maybe you do that before you state what's given to you. You state what's given to you, and which equation to use. And then choose your default direction to sort of like deal with the signs. If you kind of follow this algorithm, I think you will be fine with solving these. So let's say we have let's say we have this helicopter. I think that only has 3 wings. But yeah, kind of this is what is traveling at a velocity of 15 meters per second. Honestly, we don't even really need a big sketch for that. Let's just say this is our helicopter and it's just traveling somewhere in this direction. What are we given? We're given actually you tell me, what are we given?
The velocity
Okay. Do you think it is initial or final?
initial
Mhm.
and the acceleration
We're given acceleration. Very good.
and the time.
Excellent.
And yeah, we need to calculate the final velocity. So then, yeah.
Yes, we need to calculate the final velocity. Very good. So based on that, and again, gonna copy paste these equations. Okay, there we go. Which of these equations would be best suitable for us to do this question?
The first one.
Excellent. So we sketched it, we stated the given, and we know which equation to use. We're going to use equation 1. Okay, now let's choose the directions, right? This is important in this case because you see one of them is velocity is in east and acceleration is in west. So you know, let's choose the default direction. So basically it's an east-west question. So let's say east-west. Which one do you want to be your positive direction?
East.
Okay, yeah, totally fine. And then west could be negative. Perfect. So here we have V final equals V initial plus AT. Okay, V final. We don't know what V final is, so let's start with V initial. What should I put for V initial?
Negative 15 meters per second.
Negative 15 meters per second. Very good. And acceleration?
7 meters per second squared
Mhm.
times 4 seconds.
Perfect. Yeah, perfect. Let's do the math. So negative 15 meters per second times 7 times 4. 7 times 4 is just 24. So what is negative 15 plus 24 is 9 meters per second. Now, what do you think is the direction here? Is it east or west?
The direction. So
It's a positive answer. So what did you decide your positive direction was?
east.
Correct.
So then, oh, it would just, if it's west, then it would just be,
It would be negative.
oh,
If it
okay.
was negative, then it would be like west because you decided that west was negative. So your answer, when you get it at the end, it will follow your default directions that you've set. So you can look at the sign of the answer and be like, oh, okay. Because the way equations work, they will obey the default directions you've set for it. And then the answer will be directly based on that. Good?
Mm-hmm.
Okay. Yeah. So it's to me, it's always like a puzzle. Okay, this is what I have. These are the equations. How do I put it? And then you find the answer. So it could be fun. Um, a lot of students do find it really challenging, but I think the key is understanding directions, right?
Yeah.
Like once you understand directions, because the most confusing part is like, okay, the equations are given to you, questions are given to you. Where they get confused is, okay, what's negative, which equation to use, what is positive, right? And it's all on you. Like you decide your default direction. Once you do it, you put everything in based on that, and the answer obeys what you've decided, right?
Yeah.
So very good. This is good. Instead of doing five, maybe you do the rest for homework. I want to just do something from 1.6 as well. So first two are theory-based questions. So I'm gonna just maybe let's do five here. An arrow is shot straight up. So there's an arrow and it goes, straight up into the air at 80 meters per second. What do you think 80 meters per second is?
The time? Oh, wait, no. The
What's
the
the unit meter per second?
velocity.
Mhm.
So it
Is it
would
an
be the initial.
mhm, exactly initial velocity is 80 meters per second. Um, you can choose again your default directions. Again, we don't really care about left and right because it's a vertical motion. So which one do you want to be your positive direction? Up or down?
Um, Up.
Okay. Yeah. No wrong choice. Both will be correct. So yes, they will be. We'll stick with that choice. Um, okay, so that's all the information that we have. Isn't that very interesting? We only know the initial velocity, and they're asking us to find everything else. So let's see how that works. So the first part they're asking us to find is the maximum height. Now you know something about maximum height. What happens at the maximum height?
It just comes down.
It stops there and comes down, right?
Yeah.
But when it stops at that maximum height, what is the final velocity? What is the velocity at max height? Actually zero.
Zero. Oh,
Yeah, 100%. It is zero. So it's like you throw it at like 80 meters per second, it goes and slows down, slow, goes to zero. Only when it goes to zero can gravity start pulling it down. And then from zero, it slowly increases its speed and then hits your, I mean, it's an arrow, so you don't want it to be hitting you, but when it comes down, it will slowly increase its speed. But at maximum height, velocity is always zero. So this is actually super important concept. I will keep using this, and even until grade 12, you'll keep using this concept. Velocity at maximum height is zero. Okay, so we kind of know that V initial is 80 meters per second. We know V final is zero. What is the acceleration?
don't we need the time for that then? Because isn't like the change in.
Velocity over time. But
Yeah.
also in vertical motion, what causes acceleration? Where is acceleration coming from? The arrow is not
Oh,
braking.
isn't it also then zero because it's not going down?
Even when it's going up, there's what is slowing it down when it goes up?
Gravity. So is it just 9.81?
Yes,
Okay.
good. In every vertical motion, it's going to be 9.81 because the only thing that will, so when it goes up, the gravity slows it down. When it is going down, the gravity speeds it up, right? Because going down, your gravity's pulling you down, you're going down, it will speed it up. When it's moving up, the gravity's going down, it will slow it down because you're opposite directions. Slow down, same direction, speeds up. But yeah, that's what we have, and we're trying to find the max height. So we're trying to find like from here, maybe max height is here. So we're trying to find like this distance is what I'm trying to find. So again, gonna just bring this down here. Which equation would be the best suited? Because what I'm trying to find is the displacement, maximum height.
Probably the second one.
Good. Yes. Use the second equation. Let's do it. So displacement is what I'm finding, so I don't really care. Initial velocity is 80. Should I put positive or negative 80? Oh, we don't know time. We can't use it because we don't know time. We gotta, oh, second equation is probably not the best because we don't know time. Is there any other equation you think we can use? Something that has velocities and acceleration and distance, but no time?
So you could do. So we're just trying to find the
Displacement.
displacement. Oh, but we don't need to find time.
Not yet.
Okay, so maybe the third one.
Yeah, that would be the best, right? So use the third equation. Okay, so third equation is V final squared is V initial squared plus 2AD. What's V final?
The was 0,
Good.
but then
V initial.
uh 80 meters per second.
Okay, good. And positive because it's up, right? Up is positive.
Yeah.
What about acceleration? It's 9.81. Should I add the negative or should it stay positive? Where is gravity acting always?
So down, so then we add it like a negative sign.
Very good, exactly. And then D is the unknown, so I'm just going to put it as D. And then we just solve, right? So 80 squared is probably 6,400. And then this is going to be 19.62 D. And then you can move this to this direction, like make it positive. 19.62 D is 6,400. Right? Does that make sense? Just math. And then we divide. So let's see, we divide this. So 6,400 and divide that by 19.62. And that is 326.19. 326.19 meters. Now let's look at the sig figs that are given to us, which is, these are three, okay? Three significant figures. So I'm gonna round this to three sig figs, which is just 326 meters. And because it is positive sign, right? It's positive 326. It makes sense because it's traveling up. Good?
Yeah.
Perfect. The next part says, how long does the arrow take to reach its maximum height? So here we're finding time. So now you know a lot of things. Which equation can we use to find time now? First, second, third.
Maybe the first one.
Yeah, probably the best choice. Final is V initial plus AT. Again, I'm speeding up because you know velocity initial is 80, final is 0, so just putting those in. Acceleration we know is negative 9.81, and then T. Good. So again, moving this to this side, T is 80, and then divide by this on both sides. So let's see what that is. So 80 divided by 9.81 is 8.155. I'll record it to 3 sig figs, so 8.15 seconds. That's good. Okay, that's how you find time. And then it says determine the total amount of time the arrow is in the air. You could do it. I would show you how you could do it in detail with equations, maybe next time. But all of this is like very symmetrical. Like if it takes like 8 seconds for the arrow to go from the ground to the max height, from max height to ground is also going to take 8 seconds. Like it's very symmetrical that way. So the time it takes for you to go from ground to max height is the same time it takes for max height to come down to the ground. I will prove it to you next time, but in this case, you can just double the answer. And your answer is just going to be 16.31. Or like 16.3 is good enough seconds. Okay, so it's kind of like to reach max height, you took 8.15 seconds. From here to come back, also going to be 8.15, and then you just add those up, and that's the total time. Okay, are we good?
Yeah, and also I just looked at the notes you sent me. I think because like when I get it, it's in white, not black. So then
Yeah.
all the writing that's in white that you have, it just disappears. So I tried to
Really?
turn on, yeah. So like it just whenever it shares, it's like in white, and so I can't see a lot of like the writing.
Oh, that's interesting, because usually it would just convert to black. Let me see.
Yeah.
Oh, yeah, that is true. It didn't. Initially, it didn't used to do that, right? Like before you could
Yeah,
get.
it was fine before.
Mm, okay, let me see. Oh, yeah, that's happening for other students too, and they didn't tell me. Yeah, I just saw. Let me just change the switch background. Yeah. Oh, that is not good. I'm gonna just select everything and turn everything into black then.
Okay.
And then I will send you the notes after. So let me just stop the recording.